All right, so we are working today with our 6 trig functions. Okay, but first we've got to talk a little bit about some of our vocab words. Okay, so periodic is a word that we haven't talked about yet, okay, but unit circle and trig and all of that, it's all periodic. Okay, so what that means, okay, mathematically speaking, is a function f is periodic when there exists a positive real number c such that when you add it, it equals the same thing. Okay, for all of the values t in the domain of f. So what that means is if anything that is periodic is something that is repetitive in motion. Okay, like the cycles of the moon are periodic. They repeat every 28 days. If you take the day of the full moon and you add 28 days, you're going to get a full moon again. All right, so that's periodic. Okay, so sine and cosine are periodic in nature because you're looking at a circle, right? Every time you go around 2 pi, you're adding and you're ending up at the same spot. You just have another rotation. Okay, so that's an example that we can write down for periodic. If I have pi thirds and I go around one more circle, I'm still at the same coterminal pi thirds, right? I'm just at the coterminal 7 pi thirds. Or if I go around in the negative direction, I'm at negative 5 pi thirds. Okay, that's what it means to be periodic. You can keep going and going and going and going and end and start at the same spot. Okay? All right. The unit circle. Okay, the unit circle, this is what we get all of our coordinates from. This is where we get all of this information from that we talked about in the past couple of days when we filled in coordinates and radians and degrees. This is the unit circle. Okay, the unit circle is a circle given by the equation x squared plus y squared equals 1. It has a center of your circle at 0, 0 with a radius of 1. Okay? Okay, so that would be your circle. Center at your vertex, out 1 and around. Okay? Questions on those 2 vocab terms? All right. Okay, it's good to race. All right, so next we're going to talk about our trig functions. Now, you have done our 3 main trig problems or trig functions before in geometry, maybe even a little bit in algebra 2. Okay, we're doing them in pre-calculus. We're going to start by simply doing the trig functions just on the unit circle, and we'll move to right triangle trig with them later. All right, so in terms of how we use the trig functions, okay, first let's talk about pronunciation. This is the function sine. It is written as sin with theta. Do not call it sin. It is not sin, it is sine. Okay? This one is cosine. It is not cos. Cosine. I'm going to ignore you if you say cos. I'm just not even going to respond to you. Cosine. I might give you a dirty look. Okay? It is cosine. This is tangent. This is not tan. Tangent. Okay? Good. Now that we got that out of the way, let's talk about what it is. Y coordinates for sine. Okay, sine is whatever the y coordinate is at your radians or degrees. Okay, whatever it is in terms of on the circle, whatever the y coordinate is, that's sine. Okay, so sine of pi halves would be 1. Okay, that's the y coordinate. In terms of just any general circle, how we would use this with any circle, sine is y divided by r. So if you have a circle that is not the unit circle and it's bigger or smaller, you would take that y coordinate of the point you're looking at and divide it by r, and that would give you the radian. Okay? So let's do an example. Okay, I want to look at pi thirds. We're looking at pi thirds for all of our examples today. Pi thirds. Your first step is to find pi thirds on your circle. Your second step would be to then find the y coordinate of that radian on your circle. So pi thirds is in what quadrant? First. Your first quadrant. What? And it's right here, right? Yep. Okay. Here's pi thirds. What's the y coordinate at pi thirds? What's the y coordinate at pi thirds? Square root 3 over 2. Okay? If you can find the radian and you can tell me which coordinate's which, then you can do trig. Okay? All right. Cosine. Cosine is the x-coordinate of the radian or degrees on the unit circle. Or it is the ratio of x divided by your radius if you have a circle that's bigger than your unit circle. Okay? I'm putting x divided by r and y divided by r because this is how it shows you what it is on your reference sheet. Okay, on the unit circle, r is 1, so you're dividing by 1, so it's just the x and the y. All right, but on a circle that's not your unit circle, you would have to divide by whatever your radius is. Okay? But this is what it shows sine and cosine to be on your reference sheet, so I wanted you to look at that. Okay? Okay, so cosine is your x-coordinate. So we're going to find our radian, and then you're going to tell me the x-coordinate. So at pi thirds, we found it already. It's right over here. What's the x-coordinate of pi thirds? 1/2. Okay? Tangent is the relationship of the y-coordinate divided by the x-coordinate. It's the ratio or the slope. Okay? Tangent is y divided by x. Right? Y is your rise, x is your run. So tangent is the slope. So y divided by x. Or if you want to think about it in terms of other trig functions, tangent is the sine function divided by the cosine function, because sine is x and cosine is y. Okay?
Sine is y?
Sine is, yep, sine is y, cosine is x. Did I say that backwards?
Yeah.
My bad. Sine is y, cosine is x. All right, so when I want to do tangent, I have to do division. And in this case, I'm going to have to divide fractions, right? So I'm going to take my y-coordinate, square root 3 over 2, and divide it by my x-coordinate. How do I divide fractions? Keep, change, flip. You multiply by the reciprocal, right? So technically, we're looking at square root 3 over 2 times 2 over 1. And the 2's cancel out. So I'm left with square root 3 as my tangent. Okay? Questions on our three main trig functions? Okay, you've used these before. We just haven't applied them to a circle before. All right? Questions? All right, so now we're going to do our next trig functions. The next 3 trig functions are all called reciprocal trig functions. Okay, these are the reciprocal trig functions. They are secant, cosecant, and cotangent. Okay, secant, cosecant, and cotangent. Okay, the cos don't go together, by the way. So cosine and cosecant don't go together. All right, secant is the reciprocal of cosine, meaning it is 1 over cosine or r over x. So it is the flipped x, if you want to put that. Secant, you flip x. Okay, secant, you flip x. So if I wanted to find the secant of pi thirds, okay, pi thirds being the same one we used earlier, if I wanted to find secant of pi thirds, I would find the x value of pi thirds and then flip it. We just did the x value earlier. X of pi thirds was 1/2, right? What is 1/2? What is the reciprocal of 1/2? 2 over 1, which is 2. Okay, so for secant, you flip x. That's it. Just flip it. Don't change the sign, just flip it.
So what does this say? 1 over cosine?
Because that's one way to do it, is to do 1 divided by.
Oh, okay.
That's how you flip it, right? Because when you divide by fractions, you multiply by the reciprocal.
I thought it meant like the reciprocal of the actual cosine.
Yeah.
Forget.
Okay. All right. So next, let's talk cosecant. Cosecant is the reciprocal of sine. So it's 1 divided by sine, or r over y. Okay, so all you do to find cosecant is you flip the y value. Okay, you flip the y value. So cosecant of pi thirds. Find pi thirds, find the y value, then flip it. So what is it? 2 over square root of 3. Perfect. Can I have that? Is that allowed? No. Can't have that. Why can't I have that? Because the square root, where is it that I can't have it? In the denominator, right? I can't have a square root in the denominator, so I have to do something about it. What am I going to do about it? Close, but not quite. We don't want to square both. That'll change the number. Multiply by the radical. Okay? We multiply by the radical. What do we call that? What's the mathematical term to call that? Anybody remember? It's like a bonus question. Rationalizing. We're going to rationalize it. Okay, we're going to rationalize my fraction by multiplying the top and bottom by the radical that is in the denominator. All right? Okay, so we're rationalizing the fraction. We multiply by the radical that is in the denominator to get it out of the denominator. So I end up with 2 root 3 over the square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is 3. So cosecant of pi thirds is 2 root 3 over 3. questions on that?
See, a C looks too much like a parentheses.
Yeah. Actually,
Sad.
I don't make up the abbreviations, sorry. If I did, I would have chosen a different one for a few of these. Secant would be the first one I would redo. On more than one occasion, I have taken secant and done like secant of x and forgot a letter,
Yeah.
and it didn't end well for me. All right, cotangent. Cotangent is the reciprocal of tangent. So it's 1 over tangent, it's x over y, or it's cosine over sine. All three of those are different ways to find cotangent. Okay? All right, so if I want to find cotangent, I'm going to do x divided by y, right? So x is, so when I do the division, I'm going to have to keep flip change or multiply by the reciprocal. Am I done? No, why not? Because the squared bottom, what do I have to do? I got to rationalize it. I got to multiply by the denominator that has the radical in it. Okay? So I end up with square root 3 over 3. Okay? So those are your three reciprocal trig functions. So you have 3 main trig functions and 3 reciprocal trig functions. The only buttons you have in your calculator are for sine, cosine, and tangent. So you have to know how to reciprocate sine, cosine, and tangent in order to get secant, cosecant, and cotangent. Your calculators will not find secant, cosecant, and cotangent without you altering sine, cosine, and tangent. All right, which is why it was important that I put 1 divided by sine. Because if you want to find cosecant in a calculator, you're going to have to do 1 divided by sine in your calculator. Does that make sense? Okay. Questions on those just for the vocab part? Because next we're going to do some practice.
Can you let me take a look again to tangent?
Yes.
Thank you.
All right. So what I want you guys to do is to get out some pencil paper. Okay, get out something to take notes on. We're going to do 6 trig functions for 3 different angles to practice finding the trig functions of our radians. Okay? too far. There we go. All right. So step one in all of these is to find what first? What do I need in order to find all 6 trig functions? My what? I need to know where it is in the circle. Okay, after I find where it is in the circle, what's the next thing that I need to find? My coordinates. All right, so pi force is my first radian I'm looking at. Where is pi force on your circle? My first quadrant, okay? My first quadrant. Pi force is right here. What are my coordinates of pi force? Root 2 over 2 and square root 2 over 2. So that's my next step, is I'm going to write down my coordinates. Okay, and that's just to help so you don't have to keep referring back to your circle and back to your circle and back to your circle. Okay? I like to write them down to kind of have them on hand. Okay, so sine. Sine is my y coordinate. Sine of pi force is? What is sine of pi force?
Square root of 2.
Square root 2 over 2. What is cosine of pi force?
Same thing.
Same thing, right? Because x and y match, so that's nice. Tangent. What is tangent? What happens when you divide two things that are the same? Okay, if there's any tangents that you should memorize, it should be that one. Okay, tangent of all your force is going to be either a positive one or a negative one, depending on what you divide. Right? Positive versus a negative, and then positive versus a positive and all that. Okay? If you have a tangent of 1, there is only one way to get that, and that's when you divide one thing by the same thing. So things have to match in order to get a tangent of 1. All right? Okay, cosecant. What is cosecant? I have to flip, right? So I have to flip. I'm going to flip it down here. 2 over the square root of 2. How does 2 root 2 flip? Like, what do I have to do now?
Rationalize.
Rationalize. So I end up with 2 root 2 over 2. So I need to simplify next, right? Because the 2's cancel. And so I'm left with square root 2. Okay? You guys okay with that? That rationalizing process, that reciprocal and rationalize? Yeah? All right, so secant is what? Same thing, right? Because we just flipped that, so I'm going to square root 2.
I always do the same thing.
Same thing. Same flipped, same coordinate, right? So then cotangent is x divided by y. So it is also 1. Okay? Questions on that? All right. Number 2. You guys try number 2. Find it. Put your coordinates down. Work it out. I'm going to come around. See where you're stuck.
How do you get an X and Y?
From the circle, the unit circle.
So I find 5, 6.
On the unit circle.
And then look at the coordinate. Okay.
That's why it was so important that you put that circle somewhere safe. And you keep it with you and you have it every day.
We have to use this on the problem exam.
You get to use just radians and degrees. You don't get coordinates.
Oh.
Yeah, I heard Canon was your chauffeur.
Oh, yeah.
You're on the right track for putting that. How we doing? We almost done? Ready to go over it?
Yeah.
Okay. All right, so someone tell me the coordinates of 5 pi 6.
Negative square root of 3 over 2.
Perfect. Negative root 3 over 2 and 1/2. All right, based on those coordinates, what is, somebody give me what you got for sine?
1/2.
All right, somebody give me what you got for cosine. Negative root 3 over 2. All right. Somebody tell me what you got for tangent.
1/2 over, maybe? No? Yeah.
Okay. So what did you get when you divided?
Square root of 3 over 3.
Negative root 3 over 3. Do we need to see that division? We kind of already saw it, right, when we did our notes for pi thirds. Except for when we did pi thirds, this was in the cotangent spot, right? Not the tangent spot. So it's the same thing because 60 and 30 are complementary. Okay? They're their tangents and cotangents, sines and cosines all flip because they are the same triangle coordinates.
So will we be able to use a calculator?
Does that calculator, when you put it in, give you this? Or does it give you a decimal? So fortunately for me, you can't use calculators for a lot of chapter 4 because I want exact answers, not decimal answers. Now, if you want to put it in and then see which one of your answer choices equals the decimal that you got, kind of compare those, that'll work. But that's like, you have to go an extra step where you could just, know your coordinates and know your circle. I know, that's extra effort, right? All right, so someone tell me what you got for my cosecant. 2. And what do we get for secant? Perfect. So when we flip it, we get negative 2 root 3 over 3. Okay, so then what do we get for cotangent? Negative square root 3. All right, questions? You guys feel okay with that? All right, so I'm going to do pi together because we get a little bit different answers for this, and I want to make sure that we're all clear on what happens. So someone give me the coordinates for pi. Negative 1, 0. All right, so sine, it should be really easy, right? What's sine? And cosine? And what happens when I do 0 divided by negative 1?
0.
All right, so the reciprocals is where it gets a little tricky. Okay? Because what happens when I flip 0?
Undefined.
Undefined. Why is it undefined?
Just everything divided by 0 gives undefined.
Because anything divided by 0 is undefined. Can't have that. Can't have a 0 in your denominator, right? So if your 0 is under your line, it's undefined. Remember that. Okay, so then secant, what's the reciprocal of negative 1?
Negative 1.
Negative 1. And cotangent, what happens when I take x divided by y? Undefined.
So are you gonna have like undefined and 0?
So the only time you'll have zeros, ones, and undefines, zeros and undefines, is at your axes.
No, I'm saying like on the test where you have both.
Yeah, I could have like error or undefined. Okay, but the only place you have undefined answers is at your axes, because that's the only place where you have zeros as coordinates to divide by. Okay? Questions? All right, for the next 10 minutes, I'm going to come around and work with you guys. You now have the ability to work on your quick check. For 4-2, on the numbers 1 is a table of values that we just did. We just didn't do it in a table form. All right, and then you can do 2a and 2b. All right, so all of number 1, the whole table, and then 2a and 2b. So take 10 minutes and work on that, okay, because we're going to finish this out tomorrow, and then we'll be done with 4-2. And then you can do the quiz and make sure you finish all of 4-1 and 4-2 before we leave for Thanksgiving break, so you don't leave for break behind. Okay?